Hey, welcome to week 2 for ECE 1000. What we're going to be doing this week is just learning some basic concepts of analyzing some basic circuit components. And then next week we'll start getting into the simulations. Before we can actually get into the simulations, the reason I want to go over some basic components is that we want to be able to verify whether our simulations make sense or not. And so let's look at some components here. Now, our first component that we're going to spend the most time with is just a resistor. Now, if you've never seen this before, that's fine. And we'll be using it in this class, but you'll also encounter this again in other courses and get a more thorough introduction to it. And the symbol, the electrical symbol that we will be using for a resistor, and that's what's used in the simulator, is the following. It's kind of got up and down, jagged bits there, and then we sometimes put little 2 circles there. And the only reason for those 2 circles is to represent that it's got 2 connection points. Now, resistors can be used to model a lot of things. In fact, what you can use is like just an incandescent light bulb, not an LED light bulb. But an incandescent light bulb can be modeled as a resistor, and basically as current is going through that resistor, it's actually putting off light. Now, as the name kind of implies, a resistor resists the flow of current. And so when we have it here, a resistor, what we will do is we would apply a voltage across the resistor. So I'll just label that as plus minus V. And the positive and negative for voltage, of course, matters. And we want to know that because then I also want to know what's the direction of the current. Well, the current is going to flow from the positive side to the negative side. So we'll call this current, and we give current the label of I. So let's go ahead and write this down here. So R is going to be the resistance of the resistor, which the units are ohms, and they're often actually in the kilo ohm range. And then we have I, which is current, which the units for current is amps. And these are often in milliamps, and the unit we just use is capital A. And V for voltage, the units for that is volts. And the abbreviation, which gets sometimes a little confusing when we label something V here, the abbreviation for volts is also V. Now, one thing we're always going to really be interested in, and it's quite frankly what most of we're interested in, is like the current voltage relationship. Because what we can think about is that there's some kind of signal coming in, and we want to know how the resistor affects that signal. Does it affect the current of the signal? Does it affect the voltage of the signal, etc.? So how does it affect the signal? Well, for a resistor, there's a very nice, easy relationship between resistance, voltage, and current. And some of you might already know this, but if you don't, it's something that's called Ohm's law. And Ohm's law states that the voltage across a resistor is equal to the current going through the resistor times the resistance. So V is equal to I times R, or you could write it obviously as R times I. It does not matter. So let's look at a real basic, quick example here. So let's say, here, let me do example. And I don't know if you're hearing it, but one of my cats is really trying to help us make this video right now. So example, a 3 kilo ohm resistor has 9 volts across it. What is the current through the resistor? And now again, Ohm's law is so basic, we don't want to overthink it. This is really just V is equal to I times R. So I'll write my equation down. V is equal to I times R. And this should be hopefully basic enough that we should all say, hey, oh yeah, this is easy to solve because I just plug in the numbers. I have 9 volts is equal to, I forgot to put in there. I will sometimes get lazy and not put the units, but I want to put the units here in my calculation kind of on purpose here. So 9 volts is equal to the current, which is what I'm looking for, times 3 kiloohms. Now, this is a common mistake I see people making. I mean, the computation is easy, right? Computation is just I is equal to 9 volts divided by 3 kiloohms. But what I see a lot of people doing is not being careful with their units and getting an answer of 3 amps. And that answer is wrong. It is not 3 amps. And some of you might already be saying, well, of course it's not 3 amps because you see the mistake I made. And the mistake I made here, oops, wrong thing I clicked on here. Second. The mistake I made was that I wasn't careful with my units. And what I mean by being careful with my units, I have 9 volts divided by 3 kiloohms. Now, you don't have to do this next step, but that's 9 volts really divided by 3,000 ohms. And if you do that, you wind up with 0.003 amps, which we really want to write this in engineering notation, which is 3 milliamps. And so it's still the 3, the magnitude, or the digit was correct, but the magnitude was wrong. We had said it was, the mistake I had made was just doing 9 divided by 3 and get 3 amps, but it's 3 kiloohms. Now, there's lots of ways to do this in your calculator. First off, most calculators have an engineering notation mode, which is beautiful because it will automatically put it in the times 10 to the negative 3 or whatever the third power is for us when you do a computation. The TI calculators all have engineering notation. Even most scientific calculators have engineering notation. So I would recommend setting your calculator for engineering notation. But what you can do sometimes when you're entering this, I mean, you can enter it however you want. I mean, if you're entering it into your calculator, I just want to show a couple tips. You can just do 9 divided by, of course, 3,000 to get the answer, or 9 divided by parentheses 3, well, it depends on what your calculator is. I'll say 3e to the third power, because depending on your notation for your calculator, that e is representing 9 divided by 3 times 10 to the third. But it, again, depends on how you do your calculator's functions. So it doesn't really matter how you enter it in the calculator, but it's a common mistake I see people making. And for me, especially for the next homework assignment, it would be one of those that would be very frustrating to lose points for such a silly mistake. And so, and the reality is there's not, since these are such simple computations, there's not much partial credit. Now, I'm not going to go and do an example for every single type, because I can, hopefully, we can all see that I could change this example and say a resistor has 9 volts across it and 3 milliamps going through it. And then I could ask for what's the resistance. And similarly, I could also give you a current and a resistance and ask for the voltage. But I'm not going to go through all those specific cases. Instead, I'm going to just end the video here. And as you're going through the assignment, if you have any questions, please email me.